Hey folks, welcome to this week's News and Community Spotlight. We hope you have had a wonderful week. To start, Epic Games is excited to introduce support for Maxon Cinema 4D with the release of Unreal Engine 423, available now in preview. Cinema 4D support is enabled via the Datasmith plugin and opens up new potential for high-end creative workflows. With the integration, creators can natively import C4D files directly into UE with support for scene hierarchies, geometry, materials, lights, cameras, and baked animations. Plus, Cinema 4D's Save for Cineware command allows users to easily bake complex procedural motion graphics directly into real-time scenes through Sequencer. As part of the Epic Mega Grants program, we recently announced $1.2 million in financial support to Blender, the free and open source 3D creation suite. Epic Mega Grants is an evolution of our Unreal Dev Grants initiative, committing $100 million to assist Unreal developers doing outstanding work with UE or enhancing open source capabilities for the 3D graphics community. Blender's Epic Mega Grant will be delivered incrementally over the next 3 years and will contribute to Blender's Professionalizing Blender Development Initiative. Developed by a core team of roughly 13 people, Travis Strikes Again is motivated by small studios doing big things and feels like a love letter to indie games. We interviewed Goichi Suda, perhaps better known as Suda51, to learn more about how an independent spirit impacts the creative process. The legendary director goes on to explain how his mood can affect the game's fourth wall breaking humor, elaborates on what indie games inspired him for the project, and talks about how fusing multiple genres together to create a Travis Touchdown starring game that features an entirely different camera perspective and feel from past No More Heroes predecessors. If you missed our live webinar, Twinmotion Fast Architectural Visualization, don't worry, the replay is now available. In the webinar, get an introduction to Twinmotion and learn how it fits into a workflow for fast, real-time architectural construction, urban planning, and landscaping. The folks from Indefatigable and New Blood, creators of the retro-inspired first-person shooter Amid Evil, shared how they designed and developed their armory of weapons. While all of their weapons start as 3D objects, the team is converting them into 2D sprite packs. Learn more about their process for weapon creation in the full write-up. In an exercise of beauty in simplicity, Fabian Buchmeier, student at the University of Applied Sciences Ravensburg-Weingarten, impressively created an elegant motion design project using over 500,000 cubes. The shader provided a dynamic solution while remaining incredibly performant. It's time to work on your full spectrum monitor tan. The 2019 Summer UE4 Jam is about to kick off. The 5-day event will start with the themes announcement at the end of August 8th's livestream and run through August 13th. Falcon Northwest returns as our grand prize sponsor with more prizes from Intel, Logitech, Quixel, SideFX, Soundly, IGDA, DX Racer, and more to be announced. All right, time for this week's top Karma earners, who are Shadow River, Mukaroni, T. Sumisaki, Vicecore, Mo Watcher, Garner P57, DPTD, Loglos, and That Lightworker. Many thanks to these wonderful people. Be like them and hit up AnswerHub to help out other devs. You could even see your name up here. We're really excited about our first spotlight this week, the open source colorblind accessibility tool, or CAT. It allows for project-wide CVD settings without the need for post-process LUTs. Follow the thread for additional information and the upcoming release, which we've been told is quite soon. What an awesome initiative, CodeKidda. Next up is Steenberg Real-Time ArchViz, one of VizForm's most recent projects. The team put Unreal to the test, exploring its capabilities, and they definitely delivered. The scene is well composed and looks sharp. Great work. Telefrag VR, released on July 19th by Anshar Studios, is a fast-paced shooter with visceral movement and combat mechanics. Dash, shoot, and teleport around unique arenas that feature impossible geometry where there's no right side up and death can come from any direction. Thanks for tuning in to this week's News and Community Spotlight.
Hey everyone, and welcome to the Unreal Engine livestream. I'm your host, Victor Broden, and with me today I have senior technical writer Wes Bunn.
Hello.
And we are going to talk a little bit about AI.
Yeah, we got quite a bit of information to talk about regarding AI. We updated on the documentation front. All of our AI documentation has been revamped and rewritten to make it a little bit more digestible for people to get into and really start working with the system. So wanted to kind of highlight that on the stream as well as show how all of the systems work together. In today's stream, we're going to be taking a look at a project that I built for one of the local events that we've had here. I gave this talk on getting started with AI. I'd like to do some more streams down the road with some of the AI guys. Mishko wants to come on, and I know you guys have been asking for him, so you'll get your wish. He's going to join me. Probably in the next stream, we'll go into a little bit more intermediate and advanced, but previously we had someone on our team that was generating all of our AI documentation and Twitch streams, and since he left, we kind of had a void in AI documentation, so I've kind of tried to pick it up and carry the torch and continue adding, updating, and providing learning resources for AI.
Yeah, and it's not the next week's stream, but we're planning.
We're planning
Yeah.
the next stream that
That you'll be on, right? Actually, it might be one before that.
Actually, yeah.
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 We'll see what we'll figure something out. Yeah.
So I guess we could start by taking a quick look at the updated documentation pages. If you've tried to look at the AI documentation pages before, we had behavior trees and we had the environmental query system split off into two separate sections. So what I've tried to do is kind of consolidate it all down into an artificial intelligence section. You can just get to this going by our docs page, docs.unrealengine.com /engine/artificial intelligence, or you can search for it from the tree as well. But now you'll see that we have a centralized location for everything artificial intelligence. So we still have information on behavior trees and environmental queries. Previously, we didn't have anything on perception outside of Twitch streams and the occasional video tutorial. So I created a section on perception as well as AI debugging. We didn't have anything on that either. So tried to shore up some of the holes and tried to make the documentation a little bit more digestible than what we had before. I've given a couple talks on AI now. I'm still relatively new to the systems myself, but the talks that I have given have been well received by people that have tried to get into AI before. I've had people approach me afterwards and say that the concepts are starting to make a little bit more sense, how things kind of work together. So that's kind of the goal of this stream, is to kind of demystify how all these systems work together. And then in future streams, we can build upon what we talk about today. But feel free to check out the documentation pages. There's a revamped quick start on behavior trees. There's also a revamped quick start on environmental query system as well. We also have node reference pages now, which we didn't have in the past. So every node is broken down. I'd like to add examples for all of these down the road as well. Yes, EQS still is experimental, and I'd like to have Mishko on to talk about that. And whenever I come on the next stream with him, so we can see if we can get it out of experimental state. But we'll talk to him about that when we're on with him next time. But feel free to check out the documentation pages at your leisure. On to today's stream, though, I kind of wanted to talk about just the AI state of mind. It was an appropriate name that you gave for the stream. We kind of want to just tie all of the concepts related to AI together in this stream. For people that are new, if you've worked with AI in the past, this may be a bit of a refresher for you. Maybe you'll pick up something new along the way. But I kind of wanted to explain how all of these tools kind of work together and just kind of demonstrate them in a quick sample project. So what we're going to be doing is we're just going to talk really, really briefly from a super high level, what are the AI tools that are available and how they work together. From there, we'll jump into a sample project where we start working with behavior trees. We'll set up a behavior tree from scratch, set up all the different branches and states that we can get in as well. We'll also talk about perception, the perception system. We'll put this into practice in our sample project as well. There's all kinds of different perception sources that you can set up. For this particular stream, we're going to be focused primarily on sight because that's probably the most common, in addition to hearing. There's all kinds of other ones as well, and we'll show you those as we jump into the project. But we're going to be working on sight today. And then we'll jump into the environmental query system and set up a sample test case in our project. And you'll see the project here in a moment as well. We'll also show you AI debugging, how to bring up the debugging tools and how you can use those to fine tune and tweak the parameters for your AI, as well as diagnose any problems. And then from there, we'll try to wrap up with any questions that you guys have. You guys can chime them in as well. If anybody has a question, we can kind of do a quick segue and try to answer it. But for the most part, we have an agenda. We have something that we're going to try to get through together here by the end of the session. So really quickly, recapping what all the AI tools are, we're going to start out with probably the most common, that's behavior trees. As you see here on the left, it's just a simple tree structure where you can have all kinds of different states that you can be in. All of those states can have actions, which we call tasks, things that are the actionable things that you want your AI to do. On the right, we have what's called a Blackboard asset, which is going to store all the information that is needed by the behavior tree to make decisions. So these two assets kind of work hand in hand with each other. The behavior tree executes and is the decision-making process. The Blackboard is used to store information that the behavior tree needs to make those decisions. I told you it's going to be super high level. That's pretty much it for that. Perception is one of the other tools that are available to you. On the left, we have the ability to define an AI perception component within a blueprint. In today's session, we're going to be focusing mostly on Blueprint. C++ documentation is coming. Richard Hinckley on our team, I'm working with him to generate some C++ documentation to go along with the revamped Blueprint documentation that I created, because I'm not a programmer. So I could do a lot of things in Blueprint, but not so much in C++. So I will be tuning into that stream as well. So perception, we can do things like see things, hear things, predict things, when you're damaged. All of those can be set up inside of the perception system. On the right, we have an image of what's called a perception updated event. Whenever the AI perception system receives something, this event will fire off. And you can break that down and get all kinds of different information about what it is that was perceived, where it came from, how long ago we sensed it, etc. The other one is the Environmental Query System, or EQS for short. This is used to poll and test the environment. What we mean by that is if you are in the environment and you want to find the nearest pickup, you could use EQS to find the nearest pickup in proximity to either yourself or another player, etc. And then you can run that EQS query either from in Blueprint or within a behavior tree. In today's session, we're going to be doing it inside of a Blueprint. In future streams, we'll talk about how EQS can be used inside of regular blueprints as well, because that's also a common method. And then finally, we have the AI debugging tools, which is useful to provide feedback about what your AI is doing at any given moment. Here we're taking a look at an EQS query, actually, so we can see all the various points that we want to test against. In this particular example, we're trying to find line of sight to the player. And you can diagnose and see how the AI arrived at the location that it did for this particular example using the debug tools. So you can debug perception, you can debug behavior trees, EQS, nav mesh, all of that can be seen in real time for any of your AI characters. So how do all these tools work together? Recapping really quickly, behavior trees handle the logic, and Blackboards store the information that behavior trees need to execute the various branches. Stimuli is sent to behavior trees from the AI perception system. Queries about the environment itself are handled by EQS, where the results can be filtered, scored, or both, and sent to behavior trees in order to execute the various branches that you have set up in your behavior trees. Debugging tools enable you to see what your AI is doing at any given time, and all of these systems we're going to be working with here in a moment. There are some related tools that we're not going to go into too much in this stream, but maybe in future streams as well, considering nav mesh volumes, AI controllers and pawns, which are going to be needed, and we're going to be working with all of these today, but in future streams, maybe we can do a little bit more with more complex nav meshes. I saw some questions on the forums about that. We're going to keep things very, very simple today for those that are completely new, and hopefully they can see how all these systems tie together. If you'd like to follow along, you can download the sample project as well as the completed sample project, everything that we're going to create here from the link that you see here. These are available now, so feel free to download them if you'd like. We're going to be starting from the base project and building up to the completed sample project. So what I want to do is kind of show you what we're going to be creating here today really quickly. Off screen, I'm going to drag this window in. So the session that I gave about a month ago, we had an event, Unreal Academy here in Raleigh. I was tasked with giving a lecture on how to get started with AI. And that session was primarily for enterprise customers. Mm-hmm. So I didn't have characters running around shooting guns and things like that, but I still wanted to demonstrate how AI could be used, either for gameplay purposes or just background actors, things like that. So I created this sample project here. Everything that we cover in this session can be applied to any type of AI that you're wanting to create. So we created a project of a little deer here that can roam around inside the environment, and we have some deer inside the level with us. And these deer are just kind of walking around, just kind of eating or drinking, and they respond to us. So if we run up next to one, he'll kind of run away and try to hide from us. And the same with this guy over here, if we run in front of him. We're only doing sight, we're not doing sound here, so we're using EQS and perception. If we had hearing perception set up, then they would hear our footsteps. We could take this further and add that if we wanted to, but again, I did this in an hour, so we tried to keep it fairly concise. So we have two types of AI. We have this one that flees and finds a hiding spot away from us. Look like he's going to go around the corner there, which he did. And we also have another type of deer in the back here, which is a little bit more aggressive. This one actually will follow us. So if you're making a game, a hack and slash game where an enemy sees you and you want that enemy to come up next to you and start attacking you, in this instance, the deer just comes up and stands there and looks at you. But when you get to this point, you can have your enemy attacking or finding a spot to perform a ranged attack. All of these concepts can be applied to whatever type of project you're making. So this deer kind of just follows us around until we lose line of sight, or I added a cheat in here. If I just start eating, then he leaves me alone, which that's nice, I guess. So we're going to create this from scratch. All of the behaviors and everything that you see here, we're going to be creating from scratch in this session. And that's going to take advantage of behavior trees. That's going to take advantage of perception, EQS, and then we'll debug it so you can see all of these systems kind of working together. So let's pop up the project. So here is the base project. There are some assets that were created ahead of time just to give us a little bit of a leg up, like the actual deer itself, and the controller has already been assigned, just so that we don't have to do all of that from scratch, because we're really going to be focusing on all of the AI-related assets in this session. So if we play in this session here, we have just our deer. There's nothing in here. We've already created the player character, the pawn here, that can run around. We can hold shift to run, and all of this stuff is already set up. You can refer to our documentation pages if you're not familiar with setting up a playable character. We have tons of information on that as well. But what we're going to do is populate this with actual deer inside the environment. And we have an AI deer here now. If I were to drag this into the level like so, and we play, he's just going to stand there. He's not going to do anything. Literally looks like a deer in headlights, not doing anything. So we're going to give him some behavior with all of our AI tools. Now, this particular AI character is a child of our player character. So everything that our player character can do, the AI character can do as well. So that's the concept of inheritance. If you're not familiar with that, refer to our documentation pages. It's a really, really nifty aspect of Unreal Engine 4.
And the only difference there is that the AI pawn in that case has an AI controller, whereas you have a player controller.
Right. The AI controller here is assigned to this particular pawn, so they can actually give it directions and do what it needs to do. So let's go ahead and start creating some assets. So if we right-click inside of the content browser here, one second, there we go. Needed Unreal to catch up. And if we go under artificial intelligence, we have two assets that we can create. The behavior tree, again, which is used to make the decisions, and the blackboard, which is going to store information. So we're going to create both of these assets here. So we're going to start with the behavior tree, and we'll just call this BT for behavior tree, AI deer. And we'll right click and we'll create a blackboard asset as well, which is called BB for blackboard, AI deer. So now that we have both of these assets, the first thing that we're going to do is go into our Blackboard and designate the things that we need our AI to know about. So when we open it up, this is the Blackboard editor here where you can add various keys. These are all things that we can store and use in our behavior tree in order to make decisions and give information for our AI to use in the behavior tree. So we're going to create a couple in here. We're going to create a Boolean. Well, we'll call this just B has line of sight, because we're going to need to know, do we have line of sight to the player? We're going to need to know that. Another thing we're going to need to know, we saw that we had two types of deer. We had one that kind of flees from us and one that kind of follows us. So we're going to create a Boolean for that as well. And we'll call this just B for Boolean is follower, like so we could set that. We're going to create another key. This time of the vector type, just a location in space. We'll call this the move to target. So we'll say move to target, like so. And this is going to be used to tell our AI if we want it to move to a specific location. So we're going to use this. We're going to add another key of the object type now. And we're going to call this the target actor. This is going to be the player, or it could be something else as well. If you want to, if our Derek had health pickups and we wanted to specify the location of one, we could set that as the target actor and then have our AI move to that location. Well, let's go ahead and change the key type to an actor as well. So for now, these are all the keys that we have. Obviously, the more complex your AI becomes, the more keys that you may have and things that you want to know about. But we're going to try and keep this fairly simple. This is all we're going to be using. So we'll save that, and we'll close it out. And now we'll hop into the behavior tree editor, which looks like this. And if you've worked with behavior trees or haven't, or if you've worked with Blueprint in the past, it's all node-based. It's a graph-based interface where you add series of nodes, and all those nodes have some functionality behind them. The thing about behavior trees, though, they operate from top down and from left to right. So as we start adding branches to our behavior tree here, everything that's to the left is going to be probably your most important branch, and then falling back to kind of the subsequent branches. So typically when I'm setting one up, what I like to do is kind of pseudocode what I think my behaviors are going to be. So in our instance, our deer is going to be able to kind of roam around and graze. It's going to respond to the player. If it's a follower, maybe it's going to move towards us. If it's not, it's going to run away. So I kind of have an idea of what it's going to be. And I kind of like to just throw down a bunch of blocks here and then kind of add the decision-making process, how I get between those different branches. Now, your workflow may differ from mine, but that's kind of the approach that I've been taking with these. So one of the things that we're going to do here, you can see that a Blackboard asset has been assigned. This may be a little bit of a bug. If I clear this and I reselect it, we're going to see that our keys pop up. So I'm going to bring that up with Mishko as well when I talk to him next time. Yeah, I'm not sure why it does that, but when we reassign our Blackboard asset, our keys that we've set will show up as well so that we can use them inside of our behavior tree here. So first thing that we're going to do is we'll drag off of this, and you'll see that we have the ability to add what are called composites. These are essentially the flow control nodes used to dictate which branches of our behavior tree we're going to execute at a given time. We have 3 here by default, but through C++ you can add more, extend these classes, add special case things through C++ if you'd like to. Most of the time through Blueprint, these should accomplish everything that you need. But we have a selector, which is going to select between 2 different branches based on various conditions. We have a sequence, which is going to execute all of its child branches from left to right within that sequence. And then we have a simple parallel, which is going to execute a main action as well as a subtree at the same time. So if you have something that you want to do at the same time, a simple parallel may be one of the nodes that you want to use. So for this, we're going to start out with a selector here. And this is going to be really the hub of our behavior tree here. So I'm going to call this, let's just give it something a little bit more descriptive. We'll just say AI root, like so. Now from this, we're going to have pretty much 2 states that our AI can be in. It's either going to be roaming around doing its own thing or responding to the player. So we're going to have pretty much two branches here that we're going to be working with. I'm going to work backwards here. I'm going to drag off to this side, and now you can see we have the ability to add tasks as well. These are the actionable things that we want our AI to do, such as play animations, play sounds, run EQS queries, run behavior trees, sub-behavior trees, all kinds of different things, as well as custom tasks that we'll get into a little bit in a moment as well. We're not going to worry about tasks just yet. We're going to still pseudocode our behavior tree of all the states we're going to be in and then come back in and fill it out. So we're going to add a sequence as our first branch over here. And what this is going to be, let's just give it something a little bit more descriptive. We'll just say that this is roam and graze behavior. And we'll drag off of this, and we'll add another sequence node. And we'll call this, let's just say, player is the target, like so. Perfect. So we have two main branches that we're going to be executing in our behavior tree. One of the things that you may notice in the upper right are these numbers that indicate the order of operation of our behavior tree. As we mentioned, behavior trees execute from left to right and from top down. So if we had additional branches, this is the order of operation would be this branch. If we were to move this to this other side, you'll see that now this becomes 1 and this becomes 2. So where you place your nodes in the graph is kind of important. So typically I like to place the most important thing to the far left and then falling back to the least important. So we have our two branches. Let's continue. For the Roman Grays, we're going to be doing a sequence of tasks, essentially finding a location to move to, moving to that location, starting to eat. So it's going to be a series of tasks that we're going to be doing for this branch. So we're pretty much good there. For this side, however, if the player is a target, we're going to be doing some different things based on whether or not it's one that's going to be following us or one that's going to be fleeing from us. So first thing that we're going to do is a sequence, and then we'll drag off of this, and we'll use a selector node now. And we'll call this something like follower check, like so. And now we're going to select between two branches here. We're either a follower or we're not. So if we drag off of this, we'll say, let's use a sequence, and we'll call this AI, or this part of the branch is a follower. So. And if we're a deer that follows, we're probably going to move to the location of the player and then do something afterwards if we want. So it's going to be a series of tasks here. So we don't need to add anything else. But we will come to this side and we'll add, let's add a selector this time. And we'll call this not a follower. So, well, let's actually spell it right because that would probably help too. There we go. So if we're not a follower, our deer is going to do one of two things because we have a selector here. We are going to first do a sequence of actions, and that's going to be to run away from the player. So we'll call this run away, like so. And then after that, we can have another task. In our case, we're going to keep it very simple. It's just going to wait there and see if the player is gone. We're not going to do anything complex. But from a big picture sort of look, this is going to be our behavior tree. That's all we're really going to be doing. So we're going to set all this up from scratch here together. As you can see, the order of operations again, this is 1, 2, all the way down the chain, as we mentioned, the leftmost branch being executed. So now that we have the framework in place, I like to work backwards. So if we hold Alt and left click, we can break this up, and you can see this becomes the new number 1 because the rest of our tree is disconnected. So we'll set up this behavior first because this is fairly simplistic. All we're going to do is have our AI deer move to a location, start eating, and then find another place to move to, start eating, kind of just roam around. If you've played any MMO, the mobs are just kind of wandering around doing things. That's kind of what we're creating here. So if we drag off of this, now we have the ability to add tasks. So you can see there's a couple tasks in here that we could use right off the bat, one of those being a move to. There's also a move directly toward. This will ignore navigation. It'll literally move from point A to point B. If you want your AI to actually use the navigation systems, we're going to have to use a move to. So we're going to use a move to. You can see that this node is purple. It's the end of a branch. It only has an executable in. It doesn't go out. This is all we're going to be doing is move to. Now if we select this, over in the details panel, we can make one quick change. You can see we have the ability to define the Blackboard key. If we click this drop down, we created, did I call it? Yeah, it's already set. Oh, you know what? I'm going to rename this before I forget. It's not actually moved to target. Just to make it super clear, let's rename this.
Naming is important.
Yeah, naming is super important, especially when you're doing things like this. Let's call this move to location instead of actual target because it's a vector and we're moving to a location. So there we go. That's a little bit better. So we're actually moving to this specified vector move to location. So it's already set for us. Let's see. So let's go ahead and how do we specify what this vector value is? Because right now it's just 0, 0, 0. We need to identify what that value is so that our AI knows how to move to this particular location. So if you drag off of this and we look at tasks, you can see we don't have anything really to get us that information. This is where custom tasks come into play, where you can create your own tasks from the very top of the toolbar up here. We also have the ability to create decorators and services, which we'll talk about a little bit later as we start to apply those, but we can also create custom versions of those. But what this will allow us to do is specify our own custom logic behavior script that we want to execute. And in this case, it's going to be to retrieve a valid location for us to move to. So if we select this, and there's already a couple custom tasks that I created ahead of time just to save us some time as well. We're going to select the blueprint base here, like so.
That's the one that exists by default, right?
That's the default one. You'll usually see that if you haven't created them
Mhm.
already, but it has some logic in it and functionality in it that will be exposed to you when you create it. Typically, the first thing I like to do when I create one of these is immediately browse to that asset and give it a better name than the default name, because that's not going to do any use. We'll just hit F2 and call this BTT for a behavior tree task, and we'll say find random location. And as soon as we do that, you can see it actually been updated here as well. So if we go back to our behavior tree and we drag off of this now, under task, you'll see that we have this new BTT, find random location. Prefixing it like this also kind of throws them up at the top, so it's
Right.
kind of a best practice thing that we encourage. So you can see all your custom tasks are right here at the top, and then all the engine ones are below it. So we're going to assign the find random location like so. And right now it doesn't do anything. It's just a container at this point. If we double click on it, it'll jump us right to that script. But when this is executed, there's a node inside of here called execute. Let's see, execute AI. So event receive execute AI. There's also this event receive execute was a more generalized term. Whenever you're working with AI, you're going to want to use this version of the event receive execute. And it's just an event that fires off whatever's connected to this when the task is called upon. And in this instance, what we're going to be using is retrieving a valid location to move to. So to do this, what we're going to do, you can see we have this controlled pawn. So which pawn are we currently controlling? We're going to find a location around that pawn and then move to that location. So if we drag off of this, we could say cast to our AI deer. So we'll get the AI deer. So. And we can right click on this and convert this to a pure cast as we're just getting information. We're not really changing anything. We're just using this as a getter primarily. And you can see we have an out here by which we could say get actor location. You can see it spits out a vector value like so. And from this, we could say find random, let's say, get a random reachable point within a given radius. So from our current location, find a random reachable point from that. And we could specify how far out in a radius we want to look. So for this, we'll keep it simple. We'll say something like 700 or 800. In fact, we can right click on this and promote this to a variable. We'll call this radius. Like so. Let's move that down out of the way. And if we expose this, then we'll see it inside of our behavior tree, which is super helpful for doing quick tuning and tweaking. So now it's going to give us this random location within a given radius around our AI deer. Now what we need to do is actually update this move to location value. Because it's of the Blackboard type, what we can do inside of here is set value as or set Blackboard value as. You can see all of the key values are here. What we're going to be doing is setting the Blackboard value as a vector, because that's our move to location key. And you can see it has an N as the same color as well. So if we plug in our random location like so, that should work just fine. It's asking for the key that we're going to be setting, which is going to be this move to location. So if we right click on this and promote this to a variable, and we name it the exact same, called move to location, it'll update inside of our Blackboard or inside of our behavior tree automatically. Now, this will work if we plug this directly in like so. That will work just fine. However, we should handle edge case scenarios in the event that we do not find a random reachable point, which is unlikely, but we should handle it just in case. Just to handle this, I'll quickly create a branch by holding B and left clicking, connecting up our executable, connecting in the condition, so. So if we do find a random reachable point, we'll just plug that in. And if we don't, we're just going to cheat and copy and paste that, plug that in, and get our actor location. So essentially what we're saying is if we don't find a point to move to, just stay where you are, because we're just going to plug this directly in like so. All right, so with all of that set up, let's go ahead and finish this task by using a finish execute. There's other nodes in here like finish, abort, and all kinds of other nodes related to tasks that you can find on our documentation pages that cover some more complex situations. For our scenario, this should be perfectly fine. We can just plug this directly in, and mark it as successful. And you can also do some error checking if a task isn't or is successful. If it isn't successful, maybe you hop out to the behavior tree and you do something a little bit different. But for our instance, I think this should be fine. So let's go ahead and expose our move to location as well. And we compile that. We hop back over to our behavior tree. What we're going to see now is we have our find random location. We have our radius value that we can adjust. If we select that, we can make it larger or smaller. The move to location is set to our Blackboard key, move to location. So in our sequence here, what we're going to be doing is find a random location. Once this is done, move to that location. So we've created a custom task to handle that, finding the move to location for us. So to wrap this up, what we'll do is we'll drag off of this, and there's another custom task that I added kind of in the similar vein. It's this BTT grazing state. If we select this, what this allows us to do, if we select it here, over in the details panel, we have a Boolean exposed. Is grazing enabled? Can the deer start actually eating at this point? Yes, we can. So we're going to enable that. I've also set up some parameters to determine how long they stay at that point eating. So it's going to kind of randomize between 4 and 10 seconds, but we can tune and tweak that just to give it a bit of variance. So not all of our AI is doing the exact same thing. Again, if you download this project, you can hop into this and kind of see how I set this up. It's very similar to what we just did, but you can take a look at it in there if you'd like. Last thing that we're going to do for this first branch of our behavior tree is we'll drag off at the very front here. There's one more custom task that we have, and that is to set our move speed. So we're going to want to change our move speed for the deer while it's actually roaming around and grazing. Because if we were in this branch and it's running after the player, when we hop back to roaming and grazing, we probably don't want the deer running around eating unless, I guess that's what we want. But yeah, this gives us the ability to change that if we want. So while they're roaming around and grazing, we're going to set a random variance for their min and their max speed, something like 110 to maybe, I don't know, 150, something like that. But we can tune and tweak this later, which is great. So that is our first branch there of our behavior tree. It's going to be very simple. We're not going to worry about decorators and services and all that just yet. This is our only branch, so this should execute whenever we call it. There's a couple other things that we need to do. Probably first and foremost is to give our AI the ability to move around the environment. It needs to know where it can and cannot move. There's a volume called a nav mesh bounds volume. If we drag this into the level here, and we scale it up to encompass our whole level, just by hitting R, something like this. And I know I saw some posts on the forum posts about doing streaming levels with NavMesh volumes. There's also things like NavMesh proxies and how to get AI to jump over, like from from one building to the next, or from cliff to cliff, that type of stuff. That's something I think we can tackle on the next stream as well. This is base level. Here's a NavMesh bounds volume. If you haven't worked with it before, if you hit P, you can see everywhere in green is where our AI can actually navigate to. So it can actually get up on top of those rocks, and we have tools that we can prevent that if we wanted to as well. But for now, I think that's fine. So we have a NavMesh bounds volume in the level, so our AI knows where it can and cannot go. Our behavior tree is set up to execute a simple branch of our behavior tree. The last thing that we need to do is actually run this behavior tree. Just to keep things nice and tidy, I'm going to move this task into the task folder that I created, just because I like to be super clean like that when I'm setting up blueprints and stuff. So let's run our behavior tree. We're going to do that inside of the controller here. If we double click and open that up, what we'll do if we right click and we say event on possess. So this node will get fired whenever the controller takes possession of a pawn. So when the controller possesses our AI deer, this will get executed. And essentially what we're going to be doing is running our behavior tree at that point. You can see it targets an AI controller, which is why we're doing it inside of the AI controller here. Then we need to specify the behavior tree asset that we want to run, which is our behavior tree AI deer, like so. So with all of that, if we compile and we play in the editor, should see our deer kind of walking around. Did I drag him in the level? I did, didn't I? Yeah, I did. So he's kind of over here. So he's kind of just roaming around. not really doing anything, not responding to us just yet. But this is our first bit of behavior tree work. We've set up some simple behavior. I know what you may be thinking, this is super simple. You got it? Great, we're gonna move on. But one thing I did want to highlight is if you look at the behavior tree itself, you can actually see it executing, which is great for debugging. If you have issues and you're not quite sure what's happening, pop open the behavior tree editor and you can see what your AI is doing at any given time. It works much better when you have multiple monitors too, so you can kind of spread it out. But you can see that our deer is kind of very quickly setting a move speed, finding a random location, moving to it, and then starting to eat, which is our last task there.
This is essentially just an idle behavior as well, if you just had guards roaming around or...
Yeah, I mean, we could take this a step further. We could, right now we're finding a random location to move to. We could specify a path. So we could have like an array of vector values and then iterate through those each time we come into the task. So, first instance, get index 1, and then the next one, get index 2. So moving from point to point. Very simple to set things up like this inside of behavior tree. You could do this in Blueprint, but it took us 10, 15 minutes to do it inside of a behavior tree. Moving forward, we'd like to talk about, in the next stream that I'm on, Talking AI, we can talk about when to do things in versus Blueprint versus behavior trees and things like that. But we have a simple behavior up. Let's go ahead and continue with our example now. So let's go ahead and connect up this side of our branch. And again, working from right to left, I'm going to Alt-click this so that we have just this branch now. And let's move this over just a little bit more, get it out of the way. So now what we're going to be setting up is if our deer is set to a follower and it sees us, what does it actually do? So if our deer is a follower, probably what we're going to be doing is moving to the location of our player. So we can use a move to task. So, and what we did over here, we moved to a vector value. We set it to our Blackboard key here. On this side, we're actually going to be moving to the target actor, which is going to be the player that we're going to set through Blueprint. So we can change that over in the details panel by going to the Blackboard key and changing that to target actor. So move tos evaluate vector values and actors. So you can move to specific actors or a specified location. So we're going to change that to target actor. One of the other things that we can do is this acceptable radius. We're going to bump this up so it's not right on top of the player. It's set to 5 right now. We'll bump this up to something like, I don't know, maybe 200, something like that. So it gives us a bit of a buffer so he's not right on top of the player as it's moving towards it. Now, if the deer is following us and it moves to the location to our player and it reaches this acceptable radius, what does it do in that instance? We can drag off of this and add another task where we play an animation, we play a sound, we do something. But for us, all we're going to do is just wait. We're going to keep it simple. We can change the wait time too. We'll change that down to just a second. And then it'll reevaluate and see if it needs to be doing anything else, seeing if the player moved again. You can also set random deviations from that specified wait time, which is useful for that thing like paths. If you're moving from point to point, at each point you could have a random deviation so it stays for 1 to 5 seconds. You could do something like that as well, which is pretty useful. So we could, if we were making a hack and slash game and we found the player or moving to the location of that player, we could have a task where we start attacking or we go into a different branch and perform some kind of other logic. But for this example, we're just going to wait there. And that's really all we're going to be doing for if we are a deer that is following the player. So how do we determine if we see the player and if we are a follower? This is where decorators come into play. This is what's going to gate which branches of our behavior tree we can enter based on our values. To add a decorator, you can select the node here and you can right-click on it and you can add a decorator or a service. A service is kind of like something that can be used to go along with any composite nodes or tasks. So if you have something that you want to execute while a task is being active, you could use a service for that. We're actually going to use a service in a moment, so I'm not going to get too much into it. For now, we're going to use a decorator. There's all kinds of different conditional things that we can check. All of these are broken down on our documentation pages. Maybe we can have a cooldown. Maybe we can have, is that a specified location? For us, we're only going to be worried about Blackboard values. We're going to keep it very simple. So if I select this Blackboard option here, you can see if we select this now over in the details panel, we can specify what we're evaluating. So in this case, what we're saying is if the Blackboard key is follower, is set then we can execute this branch. So that's essentially what we're saying. Very, very simple. There are flow control options, which we're going to do actually right now. If the player is a target, what we're going to do, we can right-click, add a decorator for that of the Blackboard type. And we select this, and we change the Blackboard key to target actor is set. So what happens if we are over in this branch and target actor becomes set? We can also use flow control here to either abort branches that we're in or lower priority branches. So you can see we have notifier observer. It says on result change. This is if just the condition changes. We also have on value change. So if you have a Blackboard value of a vector and that vector value changes, but the condition didn't actually change, you'd maybe want to use the value change. In our instance, we're looking at the result change. So we're looking at the conditional change, which is going to allow us to abort various branches. If we click the drop down here, currently it's set to none, so if the result changes, nothing's going to happen. But we can abort our self, which is going to be this particular branch. We can abort lower priority, which is going to be this branch over here. Or we can abort both. And in this case, we actually want to abort both. So I'm going to select both here. And when we do that, you can see the nodes actually update. You can see everything that's aborted by lower priority is in light blue, and everything that's aborted by self will be in green. So you can see over here is blue. So if we're over here and this value changes, we'll jump over to this. If we're in this and this value changes, we'll jump over to that. So that's, I think that's going to be it for now. We'll come back and do a service in a moment, and I'll show you why we'll need that. For now, I think that's all we're going to need. So how do we actually get a target actor, and how do we actually set if we're a follower? We're going to hop back to the main viewport editor here, and we're going to go into our controller. And what we'll do is on the possessed pawn here, we'll cast to our AI deer. And I'll just right click on this and convert it to a pure cast. Probably should do a branch condition if you don't have the AI deer, but I'm going to leave it as it is. We're going to drag off of this, and we're going to get a Boolean value called isFollower. This is a Boolean value that I've added to this. What that allows us to do is if we have our deer in the level here, and we go over to the details panel, there's a property in here called isFollower that we can set on a per instance of this pawn. So we can have multiple deer in the level. We can have some of them be followers, some of them not. We can check this option. That makes it a follower. In fact, we can also change the actual mesh as well, just to give it a bit of a visual difference. So this is one that will actually follow us around like so. And we've also set the value there. So inside of our controller again, we have this Boolean value. We're going to update this follower key, which is a function I created ahead of time, which basically sets the value inside of our Blackboard component. So we can drag this in, plug that in like so, and plug that in. Perfect. All right, so now we have the ability to determine whether or not we're a follower. How do we actually determine if we see the player? So this is where we come into one of the other tools within the AI suite. So we've been working with blackboards and behavior trees. Now we're going to work with the perception system to allow us to perceive when we see our player. Now, perception, I saw a post on the forums about this. We can talk about this really quickly because I don't have a definitive answer for this, and I'd like to get clarification on this myself. Perception is something that you can add via the components panel up here. And you can do this on the pawn level. You could do it on the controller. I'd like to get into one versus the other, why we're using one versus the other. I did it on the controller in this instance because I have these functions here already that I didn't want to cast the controller and then update them. But if you wanted to do it on the pawn level, you could do that as well. But the post I saw was about attaching it to a specific bone so that as you rotate the head, being able to move and see. I'm not quite sure how to do that myself. I tried to do it in a previous lecture that I gave, and wasn't getting the results that I wanted, so I'm hoping that the next stream, maybe Michio and I can cover that and we can get a more definitive answer on how to do that. Because I attached it to the bone and it moves, but the actual perception just stayed where it was.
Right.
I'm sure you've tried that as
I
well.
have, yeah.
So hopefully we can get some clarification on that in the next stream. But for this, I think we'll be fine with what we have.
I'll make sure to add a note. And we'll
Sure. As always, if you guys have any questions, feel free to throw them in the forum post. We'll try to tackle them at the end of the stream. If I'm unable to answer them, we'll get them in the next stream. So let's add the perception system. As I mentioned, it's just a component. We're inside of the controller here. I'm just going to add it. If we come down, we can see we have under AI the ability to add the AI perception component as well as a stimuli source. The stimuli source is a way to auto-register something with the AI perception system. So if you have a projectile, for instance, you could add a perception stimuli source to that and then have it automatically register with the perception system. So in essence, you fire the projectile, it hits the wall, it makes a sound, registers with the AI perception system as something that you could hear. So that's one way you could use the stimuli source. Now there is PON noise emitter and PON sensing. This is a little bit legacy. This is before we had the AI perception system. You could still use those, but we're kind of steering people towards AI perception as that's kind of like the next iteration of the PON sensing component. So let's add our perception system. And when we select this, over in the details panel, we have the ability to define what it is we want to perceive. So over in the details panel, we can click the senses config, hit this plus sign to add one, and we click the drop down. Now you can see these are all the different types of things that we can perceive. So we can do things like sight, which we're going to do in a moment, hearing, that's probably the most common, these two, damage when I'm damaged by something. There's also prediction, team sense, and touch. These are covered on our documentation as well. I'd like to do more specific how-tos and tutorials for each of these moving forward as well. So you can expect those relatively soon as I continue to update the documentation. But for us, we're going to be doing AI Sight because it's the easiest to communicate how this works. So once we choose AI Sight, we can expand this and expand the sense, and we have all kinds of parameters that we can use to define how we perceive things related to sight. Oops, let's go ahead and reselect that. Let's move this over a little bit. So we can do things like, what's our sight radius? How far out do we see things? At which point do we lose sight of things? The actual cone angle that we can perceive things as well. We're going to make a couple changes in here. We're going to lower the sight radius. We'll drop that down to maybe 2,000. That might be kind of big. I'm not quite sure. Let's drop it down to, we'll drop it down to 15, like so maybe. And we'll keep this at like 25. I'm not quite sure what values I use, but we'll tune it. So we'll leave that. And then the other thing that we're going to need to do, and I saw a post about this as well, and the post actually just said detection by affiliation, question mark. That's a good one. That's a good question mark. So right now, detection by affiliation gives you the ability to designate whether something is an enemy, whether something's friendly, neutral. You can set these in the perception component, but there's no way to set this on a per pawn basis. So this is useful for, hey, I see something, is that thing an enemy or a friendly? There's no way to get that information via Blueprint. You can do it via C++, and I know you've tried this as well. I tried also using the stimuli source, so adding that component to a pawn and then having like an option in there potentially, but there's nothing in there either that you can say, hey, I'm a friendly, hey, I'm neutral. So I'd like to hopefully get this exposed to Blueprint so that
yeah, fully.
so that we don't have to do these workarounds that we're currently going to do here in a moment. So by default, everything's registered as a neutral. So we're going to set ourselves to neutral, and then we're going to use the actor tagging to designate whether it's the player that we sense or another deer, essentially. So that's all we're going to be setting for perception. If we scroll down to the bottom here, we have events that we could use. We have one called on-target perception updated as well as on-perception updated. This is just anytime we perceive something. This is on a specified target when we perceive something. I'm going to click this to add this event. And you can see it spits out the actor that registered it. It also gives us the stimulus, which you could break apart to get kind of information, such as how long ago did we see it. And this was in the slide deck as well, so it was a little bit of a spoiler. So you can see where it was received, the stimulus location, etc. So the first thing that we're going to do is when the AI perceives something, we're going to check and make sure that it's the player. And we're going to do that by using this actor here. We're going to say actor has tag. Okay? And inside of this, we could specify a tag, and we're just going to say player. This is nothing new to you. I know you've done this before, but hopefully people could see how this works if they haven't done it. So we're looking for the actor that registered our perception. That actor has the tag of player. So in order for this to work, what we're going to need to do is come down to our blueprints folder for the actual player deer here. And inside of it, We're going to search for tag in the details panel and add a tag of player. So now it has the tag player. If we compile, the one thing that we're going to need to do though is if we go back to our AI folder and this AI deer, because it's a child of BP deer, if we search for tag, it's going to have that by default. So we're going to need to clear that out so that it doesn't auto register like so. Perfect. So now that we have that, we can hop back into our controller and we have player has tag. We're going to hold B and left click to create a branch. Connect this up. Connect this up. So if it has that tag, great. If it doesn't, don't do anything. Now the next thing that we're going to check is on this break AI stimulus, was it successfully sensed? Did we sense it or did we lose sensing it? If we hold B and left click to create another branch and we connect this up and we take our sense, plug that in and hide those unconnected pins. Essentially what we have here is if we do a print string to test this, let's connect this up to the true, and we'll connect this to the false, like so. And we play, what we should see is if we run over in front of our deer here, so it saw us, but it's not responding to us just yet. And as we move around the corner or lose perception, it says goodbye. So we can perceive things with our deer. He's still eating. He's not reacting to us. We probably want to do sound as well. I'd probably want to do a hearing one because as I'm approaching, it would obviously hear us in real life as well. So right now it's perceiving us. But again, as soon as we break line of sight, it says goodbye. Now, this would work, but what we want to have happen is as the AI is actually following us, even though it loses line of sight of us, it's still going to perceive us in the world. So we need to create up a system so that it knows where we are and continues to follow us. And then after a given amount of time, if it still can't find us, then it gives up chase. So it's just kind of like a chasing behavior, something super, super simple. So we're going to set that up in Blueprint so that it can chase after us. If it doesn't see us again within X amount of time, then it'll give up chase. If it sees us again, then it'll auto-register within the perception system that it saw us again. So inside of our controller, let's go ahead and set that up. Let's go ahead and kill these now that we know that it works. And essentially, once we lose sight of something, we're going to give it an amount of time before we give up chasing the player. So we're going to use a timer for this. So we're going to say set timer by event. We're going to plug that in off the false. We're going to set the time here to something like 5 seconds for now. In fact, we can right click on it, promote that to a variable, and we'll call this the lost sight timer, like so. And if we compile, getting error because I haven't set the delegate just yet, but I wanted to show this in case you weren't aware of this tooltip. Anytime you've set a value on something and then right click it to promote it to a variable, it will store that automatically as well. If you didn't know that, just a quick tip. But we're getting this error because we need to specify a delegate that we're going to execute. So I'm going to right click on in the graph here. We're going to add a custom event. And we're going to call this just lost sight, something like that. You can see that we have this little handle here that we can plug in. Like so, if we compile, that should get rid of that error, which it does. So once we lose sight of something, we're going to execute our timer. I'm going to right click on this return value and promote this to a variable so that we have access to this handle. We'll just call this the lost sight handle because we're going to need a reference to this a little bit later. And I have some functions in here that I've created ahead of time that just updates the Blackboard value so that we didn't have to do that together. And we're going to drag this function in. So, and basically we're updating the sight key that we do not have line of sight at that point. Now, after 5 seconds, this is going to execute. And what this is going to be doing is updating our target key, which is the target actor. So, let's plug that in. So target actor is going to be null. And we're also going to store a reference to the actor that that is part of the perception system as well. So I'm going to go ahead and right click on this and promote this to a variable. Forgot to do this. We'll just call this sensed actor, like so. let's go ahead and intercept that. Plug that back in. Sweet. So what we'll do here is we'll update the target key, and then we'll also nullify that as well. Great. So if we do see the player again before this timer ends, what we're going to do is we're going to take our handle here, just control drag that in. We'll clear and invalidate that so that we don't execute that. So we'll then take our site key, update that, plug that in. This is why I created the function, so it's quick and easy to do this. And then we'll update the target key as well. Plug that in, with the target actor being the sensed actor. So we're going to plug that in like so. Super simple stuff. Should be all we need to do. Perfect. If we compile, let's go ahead and close this out. What we should see now, if we play, is that our deer, a couple things are going to happen. Let's see. He's still eating while he follows us, which is not what we want. And he's walking really slow, so it's very easy for us to get away.
It's not very.
And he's still
excited.
eating. He's super hungry, too. So, I mean, he's chasing us while he's eating. But he is seeing us, and he is moving towards us. And if we move out of sight, I guess it's easy. It makes it easier for us to demo this. If we move out of sight, he's going to give up chase and go back to doing what he was doing before, which is just roaming around and eating, which we see here. So he's back to this state here. And if I get really creative with my screen real estate here, when he sees us, now our behavior tree updates, and he's in this branch because he actually sees us. So we've set up perception, we've set up another branch, but we do need to fix while our deer is chasing us to stop eating. So let's go ahead and do that. And what we'll do for that is I created this sequence here. So when the player is a target, the first thing that we're going to be doing is not follower check. We're going to be taking our grazing state task, copy and pasting that over here, and plugging that in as our first thing that we're going to do in our sequence. Because what we're going to do is disable that so that it can no longer eat. You can see again, this is the first thing being executed before our follower check. And to keep things nice and neat, I'm also going to say that this is grazing disabled, like so, and I'll hide the properties. So it just says grazing disabled. So at a glance, you can kind of see what's happening. Grazing is disabled, great. Now we're doing a follower check. Is it one that should follow us? Then it starts doing this. So the last thing that we need to do is let's update our move speed for our AI as it's chasing the player. And to do this, we're going to use a service. We could have a task in here where we set the move speed manually to whatever we want. We could change, max speed to 400 and min speed to 300, so it's chasing after us. But then as the player's walking, the deer's still going to be running after us, which is probably not what we want. So we're going to create a service which is going to check what the player is doing. If the player's running, then the deer's going to run. If the player's walking, then the deer's going to walk. So we're going to use a service to do that. I told you we were going to come back to these, so now we're going to use it. So we're going to create a custom service for this. I'm going to click this button here to create a new service. Just like tasks, it opens up a brand new blueprint. I'm going to come in here and immediately rename that to something called BTS Behavior Tree Service Match Player Speed. Like so. And I'll move that into the services folder. Like so. And if we go in there and open that up, perfect. So unlike tasks, what we're going to use here is something a little bit different. Instead of an event receive execute, we're going to use an event tick AI. So when we receive the tick AI. Now doing all kinds of complex computation on tick is something that we try to tell people not to do, but for our instance, I think it's going to be very simple and we should be able to do that. But if optimization is a concern, tick is something that you don't want to use throughout all of your blueprints. But for what we're doing, I think it's going to be just fine.
And there's almost a time when you, where tick is the way to use it, and that's why the tool's there, and that's why you use it.
Yeah. I get that question asked sometimes in the field. When should we use it versus when shouldn't you? I mean, if you're doing line traces and things like that, those are going to have to be done on tick. You could do it on timers or something like that. Or there's also, can you do it for this one? I guess you can't. Guess not. For like in blueprints, regular blueprints, tick, you can set like the tick interval.
You can still
Can
do
you
that.
do it on
Yeah.
on receive
Yes,
tick?
so I believe in the behavior tree on top of the service, you can set how often
Oh
it
yes,
is
it's in there.
executed.
Yeah, it's in there. Yeah. I didn't know if you could do it on other blueprints. You could do it right here inside of the on the tick itself on the event. Yeah, you could do that inside of service as well.
Maybe
Which I'll
it's a-
show that in a moment.
Yeah.
So what we're going to be doing is we need to get what the player is doing, and then we also need to update what our AI is doing. So for the controlled pawn, we'll drag off this and we'll cast to the AI deer so that we have that. And inside of our AI deer, there is a function that I created called set or update walk speed, I think it was called. Yeah, so update walk speed is what we're going to be doing. And you see it takes in a float value. What we will want to do is get the player character. And we can drag off this and cast. Actually, yeah, we'll cast to the regular deer. So. And we can get the movement component. And that's going to give us access to the max walk speed, which is how fast our character is actually moving. And you can see it's a float value. We could plug this directly in, but that's going to mean that our deer runs exactly as fast as the player is. So I'm just going to offset this a little bit. Instead of a direct 1-to-1, we'll just say 0.9 or maybe 0.7, just to offset, like so. Cool. So if we go back to our behavior tree and we right-click on this, now we have the ability to add that service that we added. And you can see it's added in green there. If you select it, like you were just mentioning, there's the tick interval, which you can do here. I just didn't know if you could do it on the tick itself, but I guess you could do it here. So if you don't want this to tick every frame, if we don't need it to tick every frame, you could change the interval here as well.
Is it possibly in class settings for the task itself? I wonder if you can set a default. I've actually never looked
On
at
the
that.
in the actual service itself?
Yeah.
Don't actually know.
Yeah.
Oh, it is. Oh,
Right
sweet.
there.
You do it right
So
there.
you can
So
set
you
a
did it just
default.
global. Yeah,
Mhm.
global. So it'll just do everything. Yeah, that makes sense. Sweet. Good to know. All right, so with all of that, if we play, what we should see now, if our deer sees us and we start walking, it should start walking. It stopped eating. If we start running, then it starts running as well. So we're getting somewhere. He's still moving a little bit slower, and we could tune and tweak that value, but now he's following us around, and we can, again, lose sight by going behind this rock. And he kind of gives up. Ah, he saw me again, so he's still chasing me. But I added this. If I start eating, then he just leaves me alone. Get out of here. So let's keep going. We have one more branch to do. That's if our AI deer is one that should not be following us. It's one that's actually going to flee from us. Let's go ahead and set that up. So we'll connect this branch here. And we're going to use a Blackboard condition here. We're just going to say decorator, the Blackboard type. And we'll set is follower is not set. Okay. So if follower is not set, what we're going to do is we're going to run away, but only if we have line of sight to the player. So we're going to right click on this and we'll say add a Blackboard value. We'll say has a line of sight is set, like so. If it's not, all we're going to be doing is just waiting. So we'll bump this down to like 1 second. So the reason I didn't add the wait here inside the sequence, I want this to be the primary task. If we see the player constantly just run away, don't worry about waiting, just run away. Once I finish running away and I get out of line of sight from the player, then come over here and wait or do whatever other action I want it to do. Because I had somebody ask that when I gave this presentation before, when I just included in the sequence. That's probably why. So that it just executes what we want it to do in this particular task here. So if we're running away, we're probably, as you guessed it, going to be moving to a location. So we're going to say move to. And we are going to be moving to a location, not a target actor. The other thing that we're going to need is we're also going to update our player speed here. So I'm just going to copy this task, or our AI's speed. Let's connect this up. So, and we'll set the move speed of our deer as they're running away to something higher, like 400, maybe to 450. I don't know. I think that's good. Perfect. So the last thing that we have to do is specify where are we actually moving to. We're changing the move speed when we see the player to make it run faster. Where are we running to? Once we have that, run there. This gets into the third tool, that's the environmental query system. So now we're going to use EQS to pull the environment around the specified deer in question, pop up a bunch of different points, and what we want to find is any point that doesn't have line of sight to the player. That's going to be a point that we could potentially move to. There's additional test cases that we could add. We could say something like get the furthest point away or get the one nearest to me. That's what we're going to use EQS to do. So EQS is experimental still. I don't have an answer of when it's coming out of the experimental state, so you will need to enable it if you haven't worked with it before. If you go to Editor Preferences under Edit, I did click that, right?
You did.
There we go. All right. And we go to Experimental about halfway down. There's an AI section. There's only one option to enable the environmental querying system. So go ahead and check this option. And when we do that, we come back. I'm going to hop into the EQS folder here. We can right-click under Artificial Intelligence. Now we have a new asset, the environmental query asset. So let's go ahead and add this. And we'll call this the EQS Find Hiding Spot, like so. If we double-click and open this up, this is the environmental query editor. It looks very similar to the behavior tree, except this one says behavior tree, and this one says, the other one says environmental query. Environmental queries have a single branch that we're going to be executing from top down. The test that you add to those line traces are usually given preference, so those are going to be at the top. But what we are going to use instead of composites and tasks, we're going to be using generators and tests. So generators are going to produce the items that we want to test against. So we can test against various actors, we can test against current locations. For us, what we're going to be using is a grid. There's all kinds of different points that we can test against, but for our instance, a grid is going to work just fine. And what that's going to do is create a simple grid around the querier. So in this case, the AI itself. So generate a grid around that AI querier with the parameters that we specify. So over in the details panel here, we can say how big that grid is, what are the distance between all the individual points on that grid. We're going to set this to something bigger than 500. We'll set this as something like, we'll say 1200, like so. And the space between all of the points, we'll set this to something like 300, I guess. Optimization should be a concern for you when you're using EQS and setting up something like this. If you have something that has a grid of 5,000 by 5,000 with the space between them of just one unit, you're going to have a ton of items to test against. And that's just going to bog down performance. So this is kind of a balancing act. There is no right or wrong answer. You're just going to have to play test it, tune it, tweak it for yourself. But generally, you're going to want to have some space between all of the items if you can get away with it. You don't necessarily need to have things right on top of each other. So we have the items that we want to test. Now you can see we can right-click to add tests. So we're going to right-click on this, and now we can add various types of tests. Again, we didn't have this documentation before. Now we have node reference for all of these types of tests that you can add. As with anything, C++ can be used to extend this. You can have custom tests, custom generators, custom logic that you want to do, which hopefully we'll get into a little bit later in our next stream of AI. For us, we're only going to do a couple tests. We're going to keep this very simple, just so that it hopefully makes sense. First thing that we're going to use is a trace, which is just a line trace from one point to another, getting anything that intersects that line in between those 2 points. So if we select this, see over in the details panel, we can define the purpose of this test. What's going to be the purpose of this test? Is it used to filter out items? Is it used to score items? Is it used to do both? In this particular instance, we're using this just to filter out items. We're performing a trace from point A to point B. Point A being the item that is produced on our grid, point B being the player itself. from those 2 points. If we can see those, we want to filter those out from our EQS query. We don't care about those because we only want points that don't have a line of sight to the player. So we're going to say filter only for this. Okay. Now we need to provide the context. There's also options that you can use in here to define the trace itself. For our purposes of visibility, a line trace is going to be perfectly fine, but if you need custom things, you can come in here and make those adjustments. But one of the things that we do need to do is provide the context. You can see it's the other end of the trace test here. And that's going to be the player, which we have no notion of a player inside of this. So we need to create that context, which we can do in Blueprint. So we come back here and we create a new blueprint. If we expand all classes, it's going to be of the environmental query context blueprint base type. So we can call this EQC for environmental query context, player context, like so. If we double click and open this up, all we're going to do is override a function in here. There's 4 overridable functions. We can provide a single location, a single actor, locations, or actors. In this instance, we're just going to be using a single actor. If we were doing something like pickups and we needed to know where all those actors are in our world, we could use an actor set. For our instance, we're just going to use a single actor. And all we care about is the resulting actor. So we can say get player character, plug that in as the resulting actor like so. Compile that, and then hop back to our EQS query, specify the context now as our player context. So now we know that we are using player character as the context. And that's all we're going to do for our trace. Super simple. We're going to add another test though. We're going to use a distance check now. And if we select this, the purpose of this test is to actually score the test. So we're going to weight our results based on distance and our line trace. And you can see it's tracing to the context querier. So in this case, we're preferring the AI, the items that are furthest from the AI itself is what we're actually going to be using. We're going to come back in a little bit later once we start debugging and showing you what happens when you make some changes to some of these settings. So suppose we wanted items that produced not line of sight to the player, but does have line of sight. So if the player's behind something, move to a location where it has line of sight. Right now, we're doing the inverse of that. We're trying to find points that don't have line of sight. But if you're making a shooting game and you want the player to move, the AI to move to a location where it has line of sight to the player, you could use this. We would just flip the result here, change the bool match, so we'd prefer the inverse. Same with distance. For now, I think this is all we need to do. We'll add one more test in here. We'll just do a pathfinding test, discarding. Let's go ahead and filter out ones that we do not have a path to. So that's going to be our EQS test. It's going to be super simple. That's all we're doing. What we need to do now is hop back to our behavior tree and actually run this EQS query. If we drag off of this, under tasks, there's an option called run EQS query, like so. We need to go ahead and set the Blackboard value that we're going to be updating, which is going to be a move to location. We're producing a vector. We're also going to set under EQS result here, our request, we're going to set it to use our find hiding spot EQS. So there's also parameters for how we want to run this. Do we want to produce the single best item? You can also do like a percentage-based thing where it returns a random one between the highest weighted results. For our purposes, we're just going to leave it as single best, but you can experiment with these options to produce the types of effects that you want. So we're going to leave that like that, and I think that's all we need to do. Of course, I'm probably going to be missing something, but we'll check it and see. Let's find our deer in the level. There he is. And let's go ahead and set him to be not a follower this time. And we'll change his mesh like so. So now that he's not a follower, when he sees us, he should flee away from us. Let's go ahead and play. So now it's going to go ahead and do his thing. And as we run in front of him, he takes off running to get away from us and try to break line of sight, which is what we want. Now we could fine tune and tweak this a little bit more if we wanted. There's going to be some issues with this that might arise here. Let's see if it happens. So technically he still has line of sight to us all the way back there, but that's the end of our grid. That's the furthest point on our test that we set up. We could bump up the items produced in our test so that it expands the grid out and it reaches a further point. Is one thing that we could do. There's another issue that might arise. Let's see. Yeah, if I stay chasing with him, he's still not going to lose line of sight, but no, he will. He broke line of sight there. So this is where debugging comes into play, where we can bring up our debugging tools and kind of get an idea of actually what's going on under the hood, why some things are working, why some things aren't. If you hit the comma key on your keyboard, that's going to bring up our debugging tools. And I have to get really creative with our screen real estate here. But you can see we have all kinds of different information. We can see what behavior tree is currently being ran. You can see what tasks it's actually executing. We can turn on navigatable paths that it's currently can get to. We could also preview EQS by hitting 3 on our keyboard. But let's take a look at perception for a second, and we'll work backwards. So perception here, the green is our in range and the pink is our out range. So those values that we set before, we could get in a situation where we're standing here and we're trying to debug our AI and we're like, we're standing right in front of it. Why is it not actually seeing us? Well, we may need to adjust our in range. We may need to push that out a little bit more so that it looks more natural when we're in range. So let's see if we move over here. So it still can't see us even though we're right within its range because I'm hovering right on that boundary. But as soon as I get in range and it actually turns around and sees me, there we go, so it saw us. And this is useful for saying things like last known location. So this information, you can retrieve that through Blueprint. So if you have like a guard AI and it sees you and then you move away, it can go to that last known location and inspect that area. I did that in another demo that I did a long time ago. But that's how you could use perception to kind of see things like this and debug what's going on with your AI at any given time. Let's kind of hop over here. We could also check out EQS. How are we getting to the points that we actually are arriving at? So if we run our EQS test here, all the ones in blue are filtered out as a part of our test. So those are invalid points. Those are not ones that we don't want to go to. The green ones in the back there, which you can see a little bit, are valid points that were as a result of our test, and they're weighted based on distance. So it chose the one in the far back there because that's the furthest point away. You can see it says winner. But again, if you change the result type, you can take the top 5%, so it kind of takes a random one from the closest ones as well. Yeah, I think that was a lot of stuff.
Yeah, it is. And I'm sure you could dig into EQS for
Yeah, there's a whole bunch of stuff that we could still cover. This is just scratching the surface. I know some of you may be saying, oh, I already know all of this stuff. But I kind of wanted to establish a baseline of here's all the tools. Here's kind of how they work together. I'm new at giving demos on AI, so I kind of wanted to present myself and say, I'm going to be your new AI guy. So moving forward, maybe we can have some more complex streams. One of the things that I was speaking to the AI guys about is like doing a dot product on when the AI is approaching you for the EQS query, making sure that it only takes points furthest away from the player. You'd have to do some math to kind of make sure that we're not retrieving points that are on the other side of the player, because I saw instances where the deer would run past me to get to a point which I kind of know how to do it, but I want to know the proper way to do it. So I'm going to work with the AI guys to maybe we can do that in the next stream. But if there's any questions that I can answer, we can try to answer those now. But that's the project in a nutshell. You can download it, pick it apart. For those of you that are new to AI, hopefully this was helpful, and you could kind of see how these systems kind of work together.
I'll go ahead and paste the link once more to the project. You can go ahead and download it.
Yeah, I popped it up as well really quickly. So both the base, both the complete project is available to download now. The stream that we based this on today, there will also be a tutorial series coming. I don't know when it will be, but it covers from end-to-end scratch, setting up the pawn and doing all of that
Okay.
as well. I know some of this stuff was kind of set up ahead of time because I wanted to focus just on AI, but from a complete end-to-end project, that tutorial series should be coming soon too.
Yeah, they were asking a little bit about which pawn class the deer was inherited from. I believe it's a character, right?
Yes.
Because it comes with the movement component.
Yeah,
And
yeah, because we wanted to update movement speed and things like that. It's all inherited. It's all set by default.
it sort of works. Yeah, we definitely have quite a bit of questions. Let's
Cool.
see. And we do have some time left, so we can go
Cool.
ahead and go through some of them.
Yeah.
They were wondering if it's recommended to use behavior trees for dialogues on AI.
If there's localization involved, I know we have like localization assets. I haven't worked with them specifically. I have seen behavior trees set up for dialogue trees. There's some on the marketplace actually as well. I've seen those set up. If you guys would like to learn about setting something up like that, I'd be more than happy to try to set something up like that. And we can talk about how it was set up once I get it put together. But yeah, I don't see why not. You could totally do it.
Yeah, that'd
Yeah.
be interesting, actually. So they were wondering, is the hierarchical task network under development currently, or just available as is?
That I'm not 100% sure. Probably as is. I know that the team is working on stuff. There's some stuff that's coming, and I'm hoping that Mishko can shed some light on this, as well as some of the other guys that I've been working with. We have some new guys on our team as well that seem eager to get on Twitch and kind of break some of this stuff down as well. So hopefully when those guys come on, they could talk more about the actual development side of AI and what's coming and what they want to do in future streams.
Yeah, I don't know. Ask Mishko.
Yeah.
It's gonna be a couple of those
Mishka
here.
used to come on. He used to come on streams in the past with my colleague, but yeah, since he's no longer with us, it had been a while since we've done one. So I was like, I'm going to do one on AI. So here we
That's
go.
why we're here. Is it possible to work with neural networks in Unreal Engine?
Ooh.
Absolutely. I know friends have
from
done
the
it.
M&E side, people have asked that. I haven't done so myself. I've been more on the game side than that type of side, but I know that it's been asked in the past, and I know that the team is working on things like that. I don't have a timeline of when that type of stuff would come.
I know it's definitely possible. I have a friend who did it, but how he did that, I unfortunately don't know. That's
Yeah.
not anything I've dug into.
Yeah, and
but-
we were talking about it off air too as well. I mean, right now we're focusing on game side of AI, but I know that I've had questions in the past on the level editing side. It would be cool to have tools in place that can auto-generate like levels for you and materials and things like that through AI, so that you don't have to manually do some of these tedious tasks. That if you set up something in AI, it could do that stuff for you. I don't know if that's being worked on internally, but it's something I could bring up with the team that maybe we could try to put some stuff together like that, because I know it's been asked for.
Yeah, also AI that sort of learns of the players, right? That's it's very
Editor
exciting.
side AI tools would be awesome.
Let's see. So they did ask about, attaching the perception system to the head bone. There was one of our viewers in YouTube actually came up with an interesting workaround that I'd be curious if it works,
okay.
which is to attach the perception system to an actor, and you attach the actor to the head bone of the pawn.
And the actor rotates. And then yeah.
It's actually a pretty interesting
Yeah.
Idea
That's
how
a
to
good
get around
workaround.
that.
I'm going to try that when I get back
Yeah.
to the desk. That should work, though.
It
In theory-
should.
In theory, yeah. Yeah. Sweet. I love this community.
That's why you're here. What about utility AI? Is it coming to Unreal Engine?
I saw a post about this, and I know Tom Lumen. I worked with Tom Lumen in the past. He wrote up a blog post on this as well. This is one of the interesting topics that I'd like to bring up with the team as well, because I know we were talking about this as well. When to do things in EQS or EQS and behavior trees versus when to do them just in Blueprint. I'd be interested to hear what the team's thoughts on that are, because I know they're pushing for the systems that they've created. Behavior trees and EQS, from my perspective so far, has been super easy to work with, because I had not touched AI until up until a month or two ago. So I've mostly been doing Blueprint and other things. But from my perspective, it was super easy to get in there and do what I needed to do. For more complex things, optimization side of things, is it better to do things in Blueprint versus behavior trees? I'm not 100% sure. This is more of a theoretical question that I think we should definitely bring up in a future stream.
Yeah, because you can still set up your own state machines in
There's
Blueprint
move to
Minecraft.
there's move to
Yeah.
commands in Blueprint, like simple move to commands. If you want just an AI to move from, or just a pawn to move from point A to point B without the logic, you could just use a simple move to function call inside of a Blueprint. So it's totally possible.
They were curious how inheritance works with behavior trees.
Inheriting, so you have a parent behavior tree inheriting functionality from one behavior tree to another. I haven't worked with that yet. I would expect that it works just like normal inheritance system in UE4. So any kind of functionality, behaviors, properties, all that stuff should be inherited to all the child classes that implement the behavior tree. That's something I'd like to work with, and maybe we can cover that as well. But yeah, I don't have a lot of experience with it just yet. From my gut reaction is that it should work like the normal inheritance system. That's a part of the UE4 framework.
Right, yeah, I'm not actually sure either, so we'll try to take a look at that. In case of networking play, the behavior tree is running on the server or the client? It runs on the server as far as I know.
That's a good question.
Because the AI controller only exists on the server.
Yeah.
It doesn't exist for any of the clients, so I'm 99% sure that it's only
Yeah.
running on the server. That's how I set up all the
So you
multiplayer
did-
games.
you did
Yeah,
some
and
stuff in
and it
multiplayer,
definitely
right?
worked that way,
Yeah.
and that's how I approach it. So
Yeah. Oh, it's a bit of a segue, really quickly. This is a shameless plug. So, speaking of multiplayer, there was a series that I had done a long time ago.
Mhm.
I think you and I talked about this
Yeah.
as well. Now that I'm on the stream, I can address this publicly. So I did that stream a long time ago. It was like one of the first things that I did. It was a pet project for me. It was fun to do, and I set it up, and it worked. Apparently, I didn't do things the proper way that I should have, which I was called out by the community. So good on you, community.
yeah,
So I'm going to SIGGRAPH tomorrow, but when I get back and post 423, we're going to revamp that entire project. I'm going to be working with Ryan Gerlieve,
that's awesome.
the networking team. We're going to start it from scratch. Hopefully we can do some streams on that,
Mhm.
and then we'll do a tutorial series end to end, setting everything up from scratch, hopefully the most optimal way.
Yeah, and I think we'll be able to get it there. Let's see. Using multiple behavior trees, running a new one for different behaviors, for example, attacking, fleeing, patrolling, do or don't?
I guess it would depend on the complexity of the
Think
behavior
so.
trees themselves. I know that you can run dynamic behavior trees as well as separate behavior tree assets. I think that's something that we're doing and some of our licensees are doing as well, just to keep things kind of nice and neat. It's also kind of like with animation blueprints, having sub-atom blueprints and nested functionality within atom blueprints. It's kind of along the same thing. You could use it for tidiness to kind of keep things nice and neat as well. But as far as an optimization standpoint, I don't know the performance impact of having multiple.
And switching them?
Yeah, I'm not sure what
sure.
the performance impact is on that, but it's totally possible and something that I would do.
Yeah, and if it is extremely complex, I think maybe actually doing it that way might be easier to work with instead of being in a massive graph, similar
Yeah.
to where you can do it in animation blueprints as well.
Yeah.
Let's see. They were asking about difference of the events receive, execute, and receive, execute AI. And I think receive, execute AI requires an AI controller.
Yeah.
I believe that's the only real difference
Yeah.
actually. So perhaps you'd have both depending on if the pawn is currently possessed by a player or player controller or an AI controller. Let's see, what is the best or the easiest way to create something like collective mind? For example, two AI actors detected by the player, but only one of them must move to it.
Only one of them must move to it. I know that we have in the Blackboard, I didn't actually show this, but in the Blackboard itself, let's go back here. So anything that we're storing, we have this property instance sync.
Okay.
So this, if you check this option, all instances of this behavior tree that is or this Blackboard that is being used by behavior tree will know about this. So for instance, if we had target actor and we set this to instance sync, anytime target actor gets updated on one instance, it would spread to the other ones as well. So they would all know about the player in this instance.
So you can think of that. Yeah.
You could use it. You could use a Blackboard for that, I guess. You could use this option for something like that.
Yeah, it's like hive mind or radio, like say they're all soldiers and they can communicate with each other.
Yeah.
It's really, I didn't actually know about that.
Yeah. It's off by default, but you can enable it.
Hive mind is off by default. Is there a node in Blackboard for executing a random child node?
And the behavior tree?
I guess they asked in the Blackboard, but I think they meant
Yeah, I
the
think I
behavior
meant
tree.
behavior tree. So executing a random child.
Random child node. So
You could
pick a
create a
random.
custom task for that, or I'm trying to think. Let's see. Yeah, you could create a custom task for that probably, or a custom decorator or service that you use to determine which of the child branches to execute. Maybe I'll create a how-to on how to do that. I don't know off the top of my head how I would do it, but theoretically, I think it's possible. I don't see why not.
This one's a tricky one. EQS in combination with instant static mesh components. Is it possible? And if so, how to get the index of a found instance? I would have to try to go through that workflow. I do know for sure that the instant static mesh components, they should affect the navigation mesh if you're using dynamic, a navigation mesh that actually updates at runtime.
Right.
That isn't any, that isn't a pawn that's using avoidance or anything like that. Using dynamic navigation mesh requires a bit of a setup,
Yeah.
and it does add a runtime cost. That's
Right.
not only memory, because it needs to do that calculation all the time and seeing if the navigation mesh has changed. So I think that would be the first step. You definitely need a dynamic nav mesh. And then I know it's easy to return the index of a found instance. I'm
Yeah.
not sure how you would do that inside like a task or if there's any difference there.
Not really. I would. I mean, it's just a blueprint.
Yeah,
It's normal blueprinting at that point. Yeah, you could pass a reference through. I mean, it's normal blueprinting at that point. Without actually going through the workflow myself, I couldn't say
Yeah, I
I
would
do it
have to-
offhand. But maybe I can update the forum post after I try some things out and try to get a solution working.
Let's see. Can you only have a square grid or change the shape of it to work with terrain? I believe it traces for on the nav mesh, and the nav mesh will.
You can on the actual grid itself under projection data. There's additional parameters here as well, so you can project up or down. I was going to actually change this because right now, if we look at our nav mesh here, when we do the grid, it's getting everything. So it's actually putting points up here as well on our test. What we could have done is we could have set our EQS query, the project up, we could have set this to 0. And what that would have done was only kept it on the 0 plane. So even though our nav mesh goes up here, it won't create points up here. It'll only
Okay.
keep it on the 0 axis here. So that was going to actually show that, but I ran out of time. I think I showed that in one of the demos I gave. But yeah, that's one of the edge cases that we could use or we could fix by using this section here. Nav mesh in general is something that needs more love. I would like to add a section on nav mesh specifically to our AI documentation. I spoke to the guys about that, and they seem on board with that. And there's some additional nav mesh things that we want to cover in terms of AI.
Agent
so
height, agent radius, and how to work with that, and sort of set it up to
dynamic
scale with the
nav meshes, like you
yeah
said, and
scale with the
streaming.
project.
When you have streaming levels in with nav meshes and things like that. So nav mesh is on my list of next documentation to create for the AI documentation section.
Yeah, the streaming levels one is interesting. I actually came across that, and my solution was just to have the nav mesh in the persistent level, and then you can load everything in.
Yeah.
Let's see. Do you have an optimization view / readout for AI?
There is. I'm not 100% sure how to enable it. I think there is one, but I'm not 100% sure how to enable it.
I believe so. You could just profile CPU,
Yeah.
and that would give you the, anything that's ticking
There's
in
a
AI and such.
There's a specialized viewer too, though, I think. I know
Okay.
Tom Lumen had talked about it. It's actually in the forum post. Somebody linked it, which I wasn't even aware of that because the AI guys didn't bring that up with me. But there is a specialized viewer for AI. I think it was on the, if you click that, yeah. So if you click that post from Tom Lumen, there was another article in there about it. I'll see if I can find it. I'll link it in the forum post as well. But that was one of the, he talked about utility AI versus using the AI systems, and that was one of the advantages to using the AI systems is because of this profiling tool that was specific for AI. So I'd have to find where it is.
I need to read this article here.
Now, scroll down in the middle. I think it was right there.
Is it right here?
Scroll down a little bit more. What's this?
This one. Visual Logger.
Oh, is he just using the
It's just
visual
a visual
logger then?
logger.
Oh, never mind. I thought it was
And
a
it's just-
specialized tool.
It's just printing his
Okay.
utility
Yeah,
AI log.
I thought Tom had said it was a specialized AI tool. Yeah, you can use the visual logger, obviously. Yeah.
Let's see. We received some new questions here since we started asking them, so
Cool.
just had to go through. Someone is wondering what the max amount of AI that the in-engine AI could produce. Really push it to the limit. Would this be possible for y'all to show down the road? We do.
Yeah. It
Yeah.
depends on the complexity of the AI too as
Mhm.
well. I mean, if you're computating all kinds of crazy things and you're multiplying that by instances upon instances of of AI characters, then it could probably bog down performance a little bit. But
Yeah, just having tons of grazing deer is very different from deer with a line of special power ups and all kinds of smart climb
all
tree,
casting
not
off,
climb tree behavior, depending on if they have
effects and things like that.
Yeah.
It just depends on the complexity of the AI, I assume.
deer climbing trees. That's where we went today. Let's see. Yeah, they're also wondering about when EKS comes out of experimental, and
Yeah.
we'll definitely bring that up when Mieszko.
Yeah, I need to bring that up. As long as I've been here, it's been experimental. So
And I've
hopefully-
used it and shipped projects with it. So,
I know.
can we get some instruction of the new group AI function? I am unfamiliar with what that is.
I don't know how new this is. Actually, I think my former colleague did a stream on this a while ago. I'd have to go back and look at it and see. But yeah, maybe that's something we could do a dedicated stream on, Group AI. I haven't used it myself yet.
Me neither. Can we overwrite the AI perception properties with blueprint variables? Some of them, right?
Yes. I know that through C++ you can create your own custom properties as well. Where's my controller? Yeah, he's talking about these properties themselves. I know through code you can. I don't know through Blueprint.
Can you
creating
set
these.
site or loose site? Or any of those?
I mean,
Right.
you can change the values, obviously.
Right.
He's talking about custom properties in here, so some kind of
I
other
see.
new property related to site, I'm assuming.
I was just curious if you can set site or loose site at runtime, if they're exposed from the perception component.
I mean, well, there's max age. You could probably use max age for that, or not max age. Yeah, max age. So using this in combination with like lose sight. So once you lose sight, once max age has been met, then it actually loses sight. I haven't tried it, but I think that's a possibility is what that parameter is specifically used for. I mean, we created the function and the timer that says after X amount of time, then do lose sight of the player. But we could potentially use the lose sight radius here. Once we're out of that radius, we're no longer on the perception system based on a specified age limit. Once it meets that, then we actually lose sight of the entity that we were tracking. So I'd have to give that a try. I haven't tried it, but I'm assuming that's what those properties are for.
And then this will be our last question for today. Do behavior trees have to tick? I believe in the back end, I believe they're always ticking.
Yeah, I don't know if there's
Maybe not. Maybe I'm not sure. I shouldn't answer that because I'm not 100%.
Yeah,
It might
That's
be
a good
entirely.
question.
It's a good question. It might be entirely event based, depending on perhaps each node in itself is running a tick when it's active. I'm not sure. Well, that's a good question. We'll make sure to bring that with Mieszko as well.
Yeah, that's a really good question.
All right, I think that was it for today.
Cool.
That was quite a bit, but it will.
Yeah.
The video will be up on YouTube. You can go ahead and scrub through it there,
Yeah.
pause, walk through, and see what Wes did here. The project is available.
Yep, it's
Go ahead.
available now. Yeah, and as I mentioned earlier in the stream, this was just a kickoff stream. I know you guys want some more intermediate to advanced stuff, and I'd love to cover that stuff. So we'll get to that in the next AI stream that I do. Mieszko has already agreed to come on with me. He's on vacation right now, so that's why he's not here, because I asked him to come on with me. But he said he will come on with me, so the next stream we do together, we will be able to answer some more of your questions and get into some more advanced AI topics.
That'll be exciting. I'm looking forward to that.
too.
And as always, make sure you fill out the survey. Let us know what you liked, what you didn't like. Everyone who participates and provides us with their email will be able to participate in a sweepstake for a Unreal Engine T-shirt. I'm not wearing it today, but you have seen it on stream before. I like to always let you know about all of our meetups that happens around the world. They are a phenomenal source of just talking with other developers, feeling like you're not the only one out in the world there trying to make really cool things happen. We have one here in Raleigh every month, and back when I was in Seattle, we ran every month, and the people you meet there, just sort of apart from the learning, but the networking part as well. Yeah, finding people who are interested in maybe your project, maybe wants to, help you work on it, and it's just such a great, more real life community that you can hang out with. It adds a lot of value to what you're working on every day. We have our community spotlights at the beginning of the streams. Let us know what you're working on. We love checking them out. We're hanging out on Twitter, our forums, everywhere else. We'd love to see what you're working on, so make sure that you tag Unreal Engine or just send us an email if it's something, you know, that's work in progress, but you want to let us know and so that we can keep our eyes out. Make sure you send that email to community@unrealengine.com. And we are definitely hungry for countdown videos right now. And so if you saw it at the beginning of the stream, the first section, we do a 5-minute countdown video, which is actually 30 minutes of development that you then fast forward to 5 minutes, send us that and your logo, and we will go ahead and put it in our reel countdown videos. As always, if you're streaming on Twitch like we do, make sure you add the Unreal Engine tag. Otherwise, it's not so easy for us to know that you're streaming. And actually, are we going to go ahead and raid someone today? I don't know if anyone brought that up in chat yet. If anyone can provide us with someone who's streaming right now, we'll go ahead and make sure that we bring you all over there. As always, follow us on social media. And then there's a thing, I mentioned it once before, but it's so valuable that I think I'm going to repeat it every time. We upload our closed captions, we upload them as a file. And so in case you're looking for a specific part of this of the stream, instead of going through it all and trying to find it, the links will be up on the YouTube VODs just a few days usually after they go up live on YouTube. And you can just download that file, Control F, and search for the topics you're looking for. And you will actually see the timestamp of when we say those things.
Cool.
So if you search for timestamp now in a couple of days, you'll probably find this specific point of the video, which is pretty cool. I'm really happy we're doing that right now because it certainly helps.
Yeah.
And then special thanks to all of you. Special thanks to Wes for coming on.
My pleasure.
We will see you in the future with some more AI streams. And then next week, I'm actually going to showing how you can do motion capture using a simple VR setup in Unreal Engine. Yeah, just a very basic thing, preparing for something that's about to come up that we are soon announcing. Teasing a little, we can't let you know what it is just yet, but we got something cooking. And without further ado, that's it for today. And we will see you all next week. Bye, everyone.
Cheers, guys.